Greetings, humanoids. It's Adam and Akbar coming at you again. This is episode 7 in our course on philosophy of climate change. Last time I looked at climate science as a body of knowledge, and today we're going to look at climate science as institutions. So we talked last time about what is known in the passive voice, and now we're going to talk about science as it should be talked about in the active voice. Who is doing the knowing? And this will inevitably be a kind of first broad brush take on a complex field, but I hope I can communicate the big picture to you so that you can then navigate through that on your own. Oh, new feature, check this out. Oh, I did that wrong, here we go. Oh, look at that, Akbar Fact Attack. Did you know that every month we are adding the equivalent of a new New York City? So think about New York City, all the asphalt, the concrete, the steel, the glass, the wires, the pipes, everything. The equivalent of that, we're adding to the building stock every month, and we're going to be doing that, oh boy, until 2060. Just to try to remember, emissions are the economy. The economy is growing. The economy is all this stuff, and it's amazing, the Anthropocene that we're living in. Akbar thought that was just mind-blowing. Look at him. He's just wigging out over there. Okay. To it. Okay, climate science. Not all climate science has to do with climate change. But climate change science, or climate science, aims to explain and predict the workings of global climate systems. Our focus today is that it's done by professionals at institutions. So Akbar told me to go through this first part quickly because, it's when I get sort of philosophically nerdy about the sociology of knowledge and the history of knowledge. And in this case, when did knowledge become professionalized, and what does that mean? I'll just try to say a few words about that. Then we'll jump into climate science, basically in the late 19th through the 20th century. It's quote-unquote prehistory, as basically university-based and government-based scientists started to really learn more and more. And then we're going to really focus on everything since 1988, and in particular the IPCC, the Intergovernmental Panel on Climate Change, which plays an absolutely crucial role in terms of being the central hub of institutionalized science. And then I got a little bit on science in the US federal government, and I'm going to need Akbar's help because at some point I'm going to actually slip over to the Word document, the lecture notes, to show you how that's a little bit different this time and to walk through it briefly. Okay, first, a little history, sociology of knowledge. I used this picture of Galileo before because it's a pivotal moment in history, and it's an important signal or metaphor for the place of science in society. We see it emerging around this time in history as a voice of authority, for it is determining what is real. Okay, what's the truth? What's real? So we have a kind of social epistemology problem. Every society has got this. How do we establish a shared sense of reality? Now, there's a lot of ways to do this. You can just have a dictator and you can bonk everybody on the head if they disagree with them, right? You could have priests, right? Catholic priests maybe in charge of deciding what exists. Plato said, Socrates said, maybe we need philosopher kings. What do we do in our society? Well, not really any of those. We, I think, basically have these institutions, and science is one of the key ones that follow these processes to come up with truth and a shared sense of reality. In the pre-modern era, you had natural philosophers. Science wasn't coined until the 19th century, but something like scientists who looked to nature, physis, and logos, the relationships internal to things, to explain the world around them, rather than to the prevailing myths or stories that were being told by the authorities. But they always existed on the margins of society, because really, kind of look at what happened with Galileo when you try to speak up and challenge the prevailing myths. It often doesn't go very well. That all began to change in the early modern era. This is where I will try to not say too much, but universities were really important as they evolved into these credentialing, professionalized knowledge production hubs, Galileo's at this pivotal moment, in the Royal Society, the development of an institution for scientific knowledge production that is respected and sort of granted authoritative voice by the king. Now you've got science on a footing to really start shaping society, and society in turn having to adapt to what scientists are telling us is going on. So I think our answer to how do we establish a shared sense of reality is really we have a community, not an individual, or a social network, following certain rules and methods. And they may not always agree, but the idea is that we at least have these institutions governed by these rules that we more or less agree on will be the processes through which we come to try to understand reality. I think the result is something like a social contract for society. I mean, science gets support and authority and a measure of autonomy in exchange for being this hub of useful, credible, trustworthy information and knowledge for society. You have the development of these peers, experts, who are policing the boundaries of a profession, who gets to speak authoritatively and who doesn't, and you have this body of peer-reviewed literature that's growing. Yeah, these institutions become gatekeepers, legitimating or credentialing, certifying knowledge, separating who knows from who doesn't know. And then, oh no, I can't see what this last bit is. I gotta move this. Oh yes, something to talk about more as the class goes on. This constitution of knowledge, and I'm using that phrase, I've got it in the lecture notes from an article by Jonathan Rauch. I really recommend you read that. This constitution of knowledge, these institutions and these rules and methods and processes are susceptible to disinformation campaigns, where the idea is that, well, you could censor them on one hand, like the church tried to do with Galileo. On the other hand, you could just flood media and society with a bunch of misinformation and disinformation. The result being people don't know who to believe, and you start disbelieving everything. And you wonder if that may not be going on in our society now. Okay, enough with that. Akbar, help me out. I'm not getting that. There we go. Okay. So in short, where are the climate scientists? This is a snip from a Wikipedia page. They're at institutions. They're mostly at universities or government institutions, some of them at NGOs, but this is not the Republic of Letters. And it's not an informal network of smart people working from their kitchens or their basement labs or something. Science is big, and it's professional, and it's networked, and it's institutionalized. Okay, so it's important historically for developing a scientific civilization, the modern age, to have this institutionalized science. It's also obviously important in the social process whereby we adjudicate and contest and try to solve problems like climate change. Just real quickly, if you think about it, scientists and scientific institutions are some of the most important participants in the social process around climate change. Scientific perspectives are often granted a great deal of authority in deciding about climate change. Science even characterizes the situation that we're in. It frames it for us, this age of climate change. Science then becomes these resources that people use to battle for their ideas. You'll notice everybody's got a scientific report that they're waving around to say this is why we should go my direction. And so science is part of your strategies for how you're going to approach a problem and try to get your preferred outcome. And then science, of course, is involved in creating the outcomes and assessing whatever outcomes come from the process. So it's all over the place. Okay, next section, a little prehistory, very quickly. This is Svante Arrhenius. Where did I, got his name? There it is. Can't have a climate change course without talking about the great Swedish scientist, the first to calculate the greenhouse effect back in 1896, I want to say. Prior to that, you had, of course, ancient speculations about weather and climate. Some good old-fashioned pseudoscience with the settler colonialists talking about how the rain will follow the plow. Somehow in our manifest destiny, when we go out and plow up marginal and desert lands, it'll get wetter for some reason. So we're going to have this climatological effect. It really wasn't until the 19th century when you get a development of a sense of deep time and some of the atmospheric chemistry basics that you can start to formulate systematic, institutionalized peer communities looking at the climate. In other words, we kind of first have to have a paradigm in place to say there is such a thing as the climate, which required knowing something about deep time in the way the atmosphere interacts with other spheres of the planet. So you had to get these pieces in place first. Once that was in place, though, by the 20th century, you had a lot of disciplines starting to develop and hone their sense of what's going on. Paleoclimatology, so the study of ancient climates, which can be done through ice cores. It can be done through looking at these ancient bristlecone pine trees, for example. Then, middle 20th century, computers give us modeling power, which is another huge part of the enabling infrastructure for climate science. Move this thing. So where do we get then? Well, James Hansen, the foremost modern climate scientist, comes along, testifying before Congress in 1988. At the time, I believe he's at NASA. Check me on that one. There's a growing consensus that humans are impacting the climate via greenhouse gas emissions. The problem was, through this, what I call prehistory, you had a development of so many scientific studies in so many disciplines that there wasn't a good way to coordinate it all, to bring it all together and say, what do we know? With what degree of certainty? What do we not know? Where do we need to turn our attention? So we needed something to pull it together and to make sense of it to help bridge into the world of policymaking. And that's where the IPCC comes in, the Intergovernmental Panel on Climate Change. So I got this little graphic here, and then I'll toggle over to our notes as well. So there on the left, there's kind of where we got at the prehistory. Thousands of scientists, thousands of peer-reviewed publications. How do we make sense of that, pull it together, curate it, filter it, coordinate it? That's what the IPCC does. It has become the most credible, legitimate place to turn for big assessments on what's the state of our knowledge, what does it mean in terms of the risks that we face, and what does it mean in terms of the decision options that we have in front of us. Now, the IPCC is connected. This is my little bridge between the world of science and the world of policy and politics. You needed a bridging organization to take that curated, filtered, condensed science into the world of policy and politics. And it's basically a treaty or a treaty organization. The United Nations Framework Convention on Climate Change, the UNFCCC. I'm sorry, we get into the world of alphabet soup pretty quickly with all these acronyms. The UNFCCC runs the Conference of the Parties, COP, and they're the ones doing all the treaties you might have heard about with climate change, the Kyoto Protocol and the Paris Climate Accord in particular. So they're this bridge between the world of science and policy and politics. And of course, that's where you find governments and other policymakers within corporations, within smaller layers of governments, non-governmental organizations, all trying to make decisions about climate, right? Way oversimplified, but that's the basics. Now, let me just add one layer of complexity here. Akbar, help me. Here we go. Of course, the IPCC is not the only credible international agency doing science and assessments that are relevant to climate policy. So another big one is the International Energy Agency, and I talk a bit about them in the notes. They're really important. In 2019, for example, their World Energy Outlook, which assesses where we are in terms of energy, renewable and fossil, and where we're going to be in the future, has big implications for where we're going to be in the climate future. And the IEA and the IPCC actually had some pretty stark differences with their forecasts or their projections looking at the future. So that can be a complexifying factor to this graph. Okay, this is on the IPCC website. I won't dwell on this, but if you're wondering, how are they organized? Well, you basically have an executive structure at the top. And then at the bottom, you've got thousands of volunteer scientists, contributors, and then peer reviewers who are marshaled and then organized into these working groups: the physical science basis, impacts, adaptation, vulnerability, mitigation. This is stuff we'll get to later. And then the greenhouse gas inventories, a task force on that. Okay. Now, running a little bit short on time here, and a lot of this is in your notes. And in fact, maybe I'll toggle over to the notes to kind of finish up, because I wanted to say a bit about the US as well. The one thing to know about the US is that the climate science activity going on here nationally is largely coordinated through the US Global Change Research Program. It's sort of like, I guess, kind of like our IPCC. So every nation is going to have their own structure for their climate science and policy. Let me see if I can share these notes with you. I haven't done this before. I hope Akbar's doing this right. So you have these notes. I'm not going to go through them exhaustively, but I've got in here kind of a timeline of what the IPCC has done. So you've got there some of the big highlights. In 92, for example, establishing the UNFCCC, 97 Kyoto Protocol, and 2010 establishing 2 degrees C above pre-industrial levels as the goal or the target to keep warming below that. 2015, the Paris Agreement moved that down to 1.5 degrees C. The IPCC goes through these assessment cycles, and we're in the 6th one now. And I say a bit about the IEA there. So you can pore over that, and I've got hyperlinks embedded in there. In the US, well, why focus on the US? I mean, one hand, I guess I'm just here, and that's what I know the most about. On the other hand, it's also important because we are the largest cumulative CO2 emitter. I've got some more stats here. Again, so the US Global Change Research Act coordinates all these agencies, and they produce a national climate assessment, which is sort of like these assessment reports produced by the IPCC. Now, in 2001, we didn't implement the Kyoto Protocol. In 2007, the EPA, which is one of those coordinating agencies, issued its endangerment finding, which said we have to regulate CO2. So the Obama administration got busy doing that. Not only did they sign on to the Paris Climate Treaty, but they adopted the Clean Power Plan and new vehicle emission standards and more to try to get implement our promises around reducing our greenhouse gas emissions. In 2017, though, the Trump administration withdrew us from the Paris Agreement, or announced plans to do that, and also later nullified the Clean Power Plan, and has been challenging and overturning lots of regulations having to do with climate change. We'll get to all of that in more detail later on, especially as we turn to the election. So let me just wrap up this look at climate science institutions. We went from a little history and sociology to the international level with a focus on the IPCC. Then we looked at the US just a little bit, and this is in more detail in your notes. I've got these 13 coordinating agencies here which do climate change research from a variety of angles, from even transportation, agriculture, defense, energy, Department of Interior, Health and Human Services. I put the EIA here, the Energy Information Administration, which is, they're not part officially of this coordinated USGCRP body, but it's an important source of information about energy. And then, of course, the National Climate Assessment, which comes out of this group. Okay, well, as Akbar says, don't be a stormtrooper. And until next time, may the force be with you.